My name is Harold Nowak. I am presenting the peeling or shortcut method used to reduce the need to check all numbers in Collatz. Collatz. S equals 3 times n plus 1 divided by 2 when n is 1 mod 2. This is odd n. D equals n divided by 2 when n is 0 mod 2. This is even n. The Collatz conjecture asserts every n eventually reaches 1. Peeling or shortcut method. It has been pointed out in other places that we do not need to see if every n in Collatz goes to 1. You can use the peeling or shortcut method. If you already know that some m eventually reaches 1, then every n whose orbit hits m is automatically safe. You never need to fully check n. You only need to check it until it enters a previously verified set. This method can be extended if we peel at successive levels. Start peeling. You do not need to check even n because even n always goes lower to odd n, so only check lower odd n values. If the lower value is 1, there is no need to check any further because 1 is equal to 1. This is at the mod 2 level. Next is the mod 4 level. You do not need to check 1 mod 4 values because they always go lower at step 2, so only check lower values. And if those lower values are 1 mod 4 values themselves, apply the rule again. Of course, if the 1 mod 4 value is 1, then that 1 mod 4 value goes to 1. So you do not need to check 1 mod 4. They are eliminated by checking lower values, and you only need to check 3 mod 4. Or, to put it mathematically, only check the residue 3 at the mod 4 level. Do not check any value that drops below its starting value. Only check the value that it drops to. If the value that it drops to has the same quality, that being it will drop below its starting value, then you would continue this process until you arrive at a value that is known not to fall below its starting value. If the lowest value is 1, then the peeling process would end there. So we could add the number 1 to the not eliminated list, but that is the Collatz conjecture. Well, that is the reasoning, and that is how peeling is applied. We can apply this method systematically through modular levels and eliminate any residue that can be proven to fall below its starting value and only retain residues that do not have this quality. The peeling method is shown in the table. So let me make it clear what the peeling method is saying. Only check residues in the list. At 256 level, all eliminated residues go lower and must end at 1 if they do not hit another residue that has not been eliminated. So for all n, we only need to check 6.3% of all values. This is a strong pruning framework, not a proof, and I believe that is a meaningful step. Thank you so much for listening. From Harold Nowak.